Good morning, everyone. My name is Sunil. Today, I'm going to talk about how graph theory can be used in plagiarism detection. Plagiarism detection is becoming more important today because huge amount of academic contents are available online. Traditional systems mostly compare text directly, but modern systems are starting to use graph theory, which allows them to analyze the structure of writing instead of just words. Plagiarism is not only about copying words directly. It can also mean copying someone else's ideas, sentences, structure, or logic without giving the proper credit. In academic environments, this is a serious issue because it reduces originality and damages academic integrity. In digital era, plagiarism has become more complex. Students sometimes create something called patchwork plagiarism, where they combine pieces of content from multiple sources. This makes detection harder for traditional systems. Most traditional plagiarism detection tools rely mainly on string matching or keyword matching. This means they can compare exact words or sentences between documents. The problem in this is that this approach is very easy to bypass. For example, someone can replace words with synonyms. They can rearrange sentences or slightly modify the structure of the text. When that happens, traditional systems may fail to detect the similarity. Because of these limitations, researchers started looking for a method that can analyze the structure of text itself, and that's where the graph theory comes in. Graph theory is a branch of mathematics used to study relationship between objects. A graph mainly consists of two components. First, nodes, which represents object. Second, edges, which represent relationship between those objects. In many real-world applications, graphs are used to model complex systems. For example, social networks, recommendation systems, web search engines, and now researchers are using graph theory to analyze text structure in documents. In graph-based plagiarism detection, a piece of text is converted into graph structure. Here, individual words or concepts become nodes, and the connection between words like grammar or sequence become edges. For example, in a simple sentence, the researchers published the study. Each word can become a node and the relationship from edges. This creates something called a semantic graph, which represents the meaning and structure of the sentence. Because of this structure, the system can understand how ideas are connected, not just what are used. Graph-based detection is powerful because it focuses on structure instead of surface-level words. This gives several advantages. First, it can detect paraphrased contents, even if the words are different. Second, it can recognize similarity even when sentences are rearranged. Third, it can understand relationship between ideas, which improves detection accuracy. This makes graph-based detection far more reliable compared to the simple keyword matching. Now let's look at a real-world example. One of the most widely used plagiarism detection tools today is Turnitin. Turnitin is used by thousands of universities around the world. It combines submitted assignments against a massive database that includes billions of web pages, academic publications, and previous student submissions. Turnitin has evolved over time from simple text comparison to more advanced structural analysis techniques, including graph-based approaches. This allows it to detect plagiarism much more efficiently. Graph-based detection process usually follows several steps. First, the submitted documents is converted into semantic graph. Second, this graph is compared with graphs stored in database. Third, the system calculates the similarity score based on the structure matches. Finally, the system generates a similarity report, which highlights potentially copied sections. Human reviewers can then check the report to confirm whether the plagiarism has occurred. Several advanced algorithms are used in graph-based plagiarism detection. One more important technique is subgraph matching. This helps identify smaller sections of text that match parts of another document. Another technique is path similarity, which analyzes the logical flow between ideas. And finally, graph edit distance, which measures how many changes are needed to convert one graph into another. These methods allow systems to detect even slightly modified plagiarism. Many research institutions are actively working on improving graph-based detection. For example, Stanford NLP Lab has developed techniques for building better semantic graphs from neural language. MIT CSAIL has focused on creating scalable graph matching algorithms for a large dataset. And even still research uses graph-based system to maintain integrity in scientific publication. These studies show the graph theory is becoming a powerful tool for analyzing text. Graph-based plagiarism detection provides several benefits for universities. First, it improves accuracy, especially for detecting paraphrased content. Second, it helps identify structural similarities that traditional systems miss. And third, modern graph databases allow fast comparison across millions of documents. Because of these advantages, many institutions are moving toward more advanced detection methods. To conclude, graph theory represents a major improvement in plagiarism detection. Instead of only comparing words, it analyzes the structure and relationship between text. This allows system to detect copied paraphrases or reorganize content much more efficiently. As academic writing and AI-generated content continue to grow, graph-based analysis will play an important role in protecting academic integrity. And that's all from my side. Thank you.